Everybody. So, just as a little preview here on things coming up, today we're going to do 5.5. It's going to be the last section before our test. So that'll be happening next week. Okay. We'll probably Wednesday or Friday. We'll see kind of how Monday goes. Okay. Not Friday can be fine.
Wait, what's Friday?
Next Friday.
Why not next Friday?
Because someone had a test.
I think that they were alluding to because they have another biology class. We'll see. We'll just play it by ear a little bit. Next class, I am going to ask you guys to do a quick integration formulas memorization quiz. So, if you guys, these guys here, that you should know because they're just the derivative formulas in reverse, right? So I will give you one half of it, you supply the other half.
Is there
You'll give us one side of the column and then the other side?
Like I'll give you integral x to the n dx and you supply this piece.
Is it gonna be every single one of them?
Maybe. Okay.
Is
So I'll give you the integral half, you would supply the...
this announcement on minor? Is there like a assignment thing on minor?
I don't remember if I put one in there yet, because I'm not even sure. I've started writing it, I don't know that I finished, proofreading or whatever.
Okay.
That's on my to-do list for today and tomorrow to make sure that's set ready to go. But this is something that's should be 5 minutes or whatever. It's like 10 of these things. Either you know it or you don't. And I'm trying to do you a favor by making you memorize this before the test. So that,
How many points is it?
It's 3 points.
like 10 points or whatever.
It is.
There'll be test points.
3 points.
There'll be 10 test points or whatever. So they're big points. Fine. You guys cool?
Yeah.
Okay. My plan here for today then, we're going to plow through 5.5. We'll take some questions. Lucas has asked about some of the FRQ questions that were on the snow day homework quiz that a lot of us haven't submitted. So if you haven't done that, try to get those submitted. I know it looks like most people started, it says in progress, but I don't know if it's you finished and you didn't hit submit at the end, or you're just got to the FRQs and this doesn't seem right, I'm not doing this. We want you to do them. That's okay, I'm just reminding you. All right. Today, what we're going to be doing is looking at how to do an antiderivative for something that included the chain. So if I have a chain rule problem and I want to anti-differentiate that back, that's kind of what we're going to be studying today. That's the goal, okay? So remember that in the last lesson, we connected anti-differentiation to the integral, right? But if I look at something like this, there is no antiderivative formula that we have to handle something like this, right? We need a new technique. And that's really going to be the next coming sections are going to be all building out some integration technique and application, and we've done most of the theory at this point. Right, if it was the integral of 2x dx, we can handle that. Even the integral of 1 plus x squared, or square root of 1 plus x squared, I don't have any antiderivative formula for that. What do I do with that? Right? So here is the method. is that if we have the integral of some chain rule derivative, we should get back a composition of the two functions, right? So, this is the idea. I need to select my u, a variable u, such that g of x, the function on the inside, is u. And I'm going to then evaluate du dx and let that be g prime. That allows me to say du is like g prime dx. Where if I do that now, this guy is u, this is du, and now I have something that looks much more handleable. Okay? I'm going to go back to that problem at the very beginning that we looked at that we couldn't handle directly. And we're going to practice using this new technique on that. Okay, this technique is called U substitution. Usually because we use the letter U as our variable substitute. So I'm going to look at this. Okay. What I'm going to look for is the function that's the inner part of the composition. What function would that be? 1 plus x squared. Okay. I'm then going to find the derivative of that. Du dx is 2x. So I can say then du is like 2x dx. So if I make my substitutions now, that's just the du. That is just a u. Everybody okay with how I substituted things in? What's the advantage now? This is something I just have an antiderivative formula for, right? So I just think about this as u to the 1/2. What's the antiderivative of u to the 1/2?
Did you just like see this stuff doing like the n plus 1 over and just, okay, that's it.
Yes, that's all I did was use that antiderivative rule. Yes. So I added 1 to the exponent divided by exponent plus 1, and I did the reciprocal and like because I had a fraction the exponent or the denominator.
Why were you able to get rid of the du? Just use the
Well, that's part of like the integral. Remember, this is like the integral operation is like that's like the symbol for the operation of taking an integral.
Okay.
So like when you do the antiderivative, the d whatever at the end is gone. It's part of, like when we do d dx for the derivative, the du is like the dx at the bottom.
Okay.
Right? It's just telling you what variable you're integrating with respect to. Is that it's okay? So I have this. Antidifferentiation is done, but I'm not. I still have one more thing to do. I want to find the antiderivative of this. Right? This has x's, that has u. What do I still need to do? Just substitute back in.
You don't have to simplify.
What's there to simplify?
Um,
I mean, you could, but there's nothing here that I would want to touch.
okay.
And you could do 2/3 1 plus x squared times the square root of 1 plus x squared or something, if you wanted to do that. I don't think that's simpler though. Right? The rest of this lesson is basically we're just going to do practice using this technique on like situations where like we've tweaked a little, oh, what if this happens? Oh, what if that happens? Oh, and show you some of the tricks that you might have to employ as we go. Okay? So just practice using this technique now for the rest of this section. Everybody feel good? Okay. We have the integral of x cubed cosine of x to the fourth plus 2. What should I pick as my u?
X to the 4 plus 2.
Excellent. Okay. My du dx is going to be 4x cubed. Right, just the derivative of that. What's the hitch? I have an extra 4 sitting here, right? See? Or no? No? Let's go for a minute. Okay. So I'd have du is going to be this then, right? If I look up here, I have the x cubed, I have the dx, don't have a 4. Is there any 4 up here? Here's the trick. I'm just going to divide both sides here by 4. So I have an x cubed and a dx, and I replace that with du over 4. Problem solved. So this is going to be the integral of cosine u du over 4. Yes, folks.
Can you explain that last part that you did at the bottom of the question? Du is equal to 4x cubed dx, and how you transform that?
I divide both sides by 4.
Okay, that's it.
That's it.
Oh, okay. So where's the du over dx? Oh, it went to the other side. Okay. Thank you.
You're welcome.
And then you put the cosine back, so that was the outside function.
Well, then I made my substitutions, right? X to the fourth plus 2 is u.
Yeah.
And then x cubed dx is du over 4.
Oh, okay.
Okay?
Kind of. It's just a cosine part.
Right. So like, just making substitutions.
Oh, okay.
Now that we've done that, can we do the antiderivative of cosine u du over 4?
Yeah.
Yeah, right? So the over 4 here, I'm just going to suck out to the front because it's just a constant. Everybody's okay there? So I can do like one of those. What's the antiderivative of cosine?
Sine plus c? Negative sine plus c? No. Yeah.
Positive sine.
Positive.
Because the derivative of sine is
Perfect.
cosine. So the antiderivative of cosine should be sine. Everybody's okay? So I have 1/4 sine u plus c. And my last step would be then to put x to the 4th plus 2 back in for u. What do you guys think? Let's do some more, yeah? Here.
Sorry, why did you bring the 1/4 in front of the, around the left side of the integral?
It's here. So I just used this property. It says if I have a constant inside my integral, I can just pull it to the front and just kind of ignore it, just like the Cooper curve is.
Okay.
Is that?
Yeah.
Okay. You guys ready to do the next one? Okay. Training wheels, 1 or 2 more, and then I'm gonna like take some training wheels off maybe on the next one, let you guys see what you can do, and then go through it. Sound good? Okay. First step, we should pick for you. Good. So du dx is going to be just 2, right? So du is going to be 2 dx. If I go look over here, do I have a 2 dx? What should I do? Divide by 2. And now I'm ready to substitute. Okay. When I make my substitution, what am I going to have? Not dx. du over 2. Everybody feel good? Okay. And now we're just ready to do the anti-differentiation. So I'll take the 1/2 out front. Think about u as u, or square root of u is 1. Yeah. The square root of u is u to the 1/2. And we have 1/2 times.
What are the halves u to 2 or 3 u?
Wonderful. Lucia, you were starting to say something?
When you so you pulled the 1/2 out front, and then it was u to the 1/2, or wouldn't it be n plus the number n plus 1, like 1/2 plus 1?
That's 3 over 2.
Oh, so you just hadn't done that yet?
We did it. Right? 1/2 plus 1 is 1.5, just 3 over 2. Or no?
Yeah. It's fine.
You look real disappointed.
It's the d over 2. Yeah, I know. It's just like pulled out the 1/2, so it's not as.
All right. Try this one. So where do you get 2? Yeah.
Who's the X on that?
Oh my God. I forgot to put the get rid of the U on that last one. Sorry. Yeah, okay.
Why does the X turn into 1 when you plug like the back in? Like the X on number?
This, why is this one here?
Yeah.
I mean, you could write it as du over -8 over. I just felt like it was cleaner to write it this way. Because this is still the same thing as right?
Yeah.
Why is it not an X over U squared?
So you're good with this. We see this and this are the same thing, right?
Oh,
You see it?
yeah.
Okay. When I do the U substitution, there should be nothing but U's left in my integral. If I still have X's left, we got problems. I gotta do some other, either I picked the wrong thing for my U, or there's some additional tricky things that we'll see on a future example on what to do. Peyton, are you happy?
I think so.
Okay, Aaron, are you happy?
Yeah.
Brooks?
I'm just curious, how do you know what to throw in the front and what to keep it in? 'Cause, like, I was looking at the first example, like, I'm using this as an example, it's like 1/4 into the front, or cosine, like, stayed at the back, and with.
You can pull a constant outside the integral.
Okay, so it's like.
Constants only.
Okay.
All right. Can we just finish up now, right? What's the antiderivative?
2U.
Good. So then we have 2u to the 1/2.
Maybe,
Well, it's over 1/2. Over 1/2.
Yeah, over 1/2 is the same as times 2.
Wow. Well, Alex, you should respect it.
Oops. Negative.
this is probably just like a arithmetic thing, but why that turns 1 minus 4 squared?
I just put the u back.
Oh, never mind, okay.
Try the next one.
Oh, I get it now.
Could you zoom in a little bit
Zoom in a little bit.
on the next question? Thank you.
You're wearing glasses there.
Yeah.
Wow.
It's okay. I just wasn't clear what I was supposed to do. I'm like, there's a lot of stuff up here. What did you need to zoom in on?
That's cool.
Yes.
I was going through that the other day. I didn't know the exact one, so it was something like this.
Maybe.
I was like, oh, I get it.
Yeah, right?
I'm proud of myself, yeah.
Yeah, well done.
Five X is easy. 5. 5 du. 5 dx. Wow. Oh yeah, okay, so yeah, 5 dx. And
You know, I'm doing good.
Why is it e to the?
What just happened?
No, it's e to the u.
Oh, sorry.
I thought the same thing.
Yeah.
That's my bad.
No.
Again, if it's not clear, you can ask. I fully acknowledge that my penmanship is less than spectacular. It's not as bad as Pat's, but like, you know.
Why is it equal? That is really bad.
Well, someone said slow down. So I just stopped. Yeah, I just was like, okay, I'll stop. It's not actually equal to 1.
Yeah.
I was just cranking, and someone's like, whoa. It's like, okay, we'll pause.
Yeah. Keep going. So
Okay.
No, I'm trying to
How big is it because the header is
Mm-hmm. Yeah, exactly right. Very good.
Wait, what did he say?
It just went from EU to EU5X. E is the antiderivative change.
Yeah, it's like, why is the integral of e to the u still just e to the u? Because it is. Because it is. All right. This one we're going to do together because some tricky stuff happens here.
Oh boy.
It's a good trick. It's an important trick to see because I will promise you on the exam I'll use a similar trick. So this is a problem that I'd make a note of in your notes. To be like, hey, make sure I review the trick in this one because it will be on the exam. Okay? What should we pick for you?
1 plus x squared.
Yep. du dx is?
2x.
Notice there's no 2 here, so we'll divide that over.
After that.
Does everybody feel okay?
Yeah.
Now let's start trying to substitute stuff in. What do you notice is the problem here? Yeah, this is like x times x to the 4th. So I have like that much, but I still have an x left. Oh no. What do I do? Did I do something wrong? Nothing wrong. Okay, there's a trick.
You still have x to the 4th left, right?
I still have this x to the 4th
Okay.
that I need to write in terms of u. If I take this, I know that u minus 1 is equal to x squared, right? Is everybody okay with that?
Yeah.
You don't want a different color. I thought I picked a different color.
U minus 1 times
To the second, you mean? Yeah. So we're going to have then square root u, and then u minus 1 squared, and then du over 2. U minus 1 is x squared. X to the 4th is x squared squared, right?
So why couldn't you just do, like, x to the 4th is x squared squared?
Yeah.
Well, like, x times x times x times x is also...
Great. That I agree.
Right, so then, no, but that's what I'm saying, like, why do we have to go through that if we could have just done, like, the same thing with the regular x that we had down there?
Because I only have one of them is going to give me a du. I don't have a bunch of dx's. I don't have 5 dx's,
Oh.
right?
You do
I only have one dx,
Okay. Got
right?
it. Mm-hmm.
Is that?
Yeah.
Okay. So everybody good as to how we're gotten to here. Now this is something we can anti-differentiate, but not as it's currently written. I'm going to have to do some algebra here to get it to a form where I can handle it. What am I going to need to do? Excellent. Mark says expand.
Oh, you gotta bring the constant out to the front.
Yep, and we can pull that constant out front. Sure. Do that right now. Everybody's good on the expansion that happened? Just foiling it out. U minus 1 times U minus 1. Okay. Now what should I do? Still can't anti-differentiate the way it's written.
You distribute the U and F.
Yeah. Yeah, let's do that. And now we are okay. Because each of those U to the powers are just like power rule antiderivatives, right?
I thought one term was like
Distributing.
Oh, never mind. I see it.
Okay. Okay. Antiderivative of U to the 5 halves. And then antiderivative of U to the 3 halves. I think that, right? 2/5 U to the 5 halves.
Like the minus.
Yeah, I'm going to. I just don't want to do too much in one
Yeah.
step, so you guys can see the antiderivatives happening. But yes, we're gonna do some simplifying here in just a moment, and then we have 2/3 U to the 3 halves plus C. Everybody's good? I'm going to distribute the 1/2 through. And I'm also going to put the U's back in. Meredith,
You just left your answers.
you have to put the X's back in.
Oh, yeah.
It will not be full credit if you don't put the X back in at the end. Whether you just simplify the 1/2 or not, the IB won't care, or the AP won't care. I don't really care. But you have to put the X's back. Is that?
Yeah.
Okay. Does everybody feel okay? So this trick of like, what do I do if like, I go to substitute my stuff in and I still have X's left over? That trick you will see again on your exam, promise you that. Test 5 coming up next week. That trick will happen again. Okay, so if you're studying, this is a good problem to review again.
Last time, one question was, why does it equal U minus 1? Because I know,
I just subtracted 1 from both sides. U is equal to 1 plus x squared. I just subtract 1 from both sides, so I get an equation.
okay.
Just x's are equal to u, so I can make some more substitutions.
Yeah, I didn't know you could use the same one.
Right, and you wouldn't think to do that.
Yeah.
Right, that's the point of like showing you the trick. Is like that's like not an obvious thing to want to try to do.
Thank you.
Yep.
Mr. Cooks, could that trick be like with that to any exponent? Or does it have to be like odd?
No, it could work lots of different places. Yeah. All right. Integral tangent x dx. What's the antiderivative of tangent? Mm-hmm. That's the derivative of tangent of secant squared.
Wait, 1 over
1 like divided by x squared.
1 over.
That's the derivative of tan inverse.
Oh, square root of 1 plus.
1 over 1.
We don't have it. We don't have a formula for it. That's what I was trying to get you. There isn't one. How are we going to do this? There's Mr. Kulik's making this in the U substitution section, but there's one function here. What am I supposed to be doing? Yes. Yeah. That's right. Okay. What should be my U? Cosine. Why the cosine? Because it's the denominator, right?
What subject is?
Because the way I'm thinking about this in my head is I'm thinking about it when I looked at this, this is what it's going to look like to me. Where's the composition at? It's the cosine, right? That's in the function 1 over x. The sine, that's just like, that's no composition going on there. Do you see it now, after I rewrite it, why the denominator is the one you want to pick?
Yeah.
Okay. The derivative of cosine is negative sine. So negative du is going to be sine x dx. Does everybody feel okay? What's the antiderivative of 1 over u? Natural log u. Natural log absolute value. I'll take the negative sign out front. Why is there the absolute value there? Because the natural log you can't do the natural log of a negative value. So you have like a domain restriction thing happening as you're stepping back through the antiderivative. Most of the time it probably won't matter, but you should write it. Okay. And my last step then would be to put the u back in.
Can you explain one more time like how you know it's absolute value?
Well, I mean, the simplest explanation is that that's the formula.
Oh, okay.
You know, like it's always going to be that way.
That's
Okay. Is that you satisfied with that?
Yeah.
Okay. I don't want to belabor the point. Okay. Let's do this now for a definite integral. So remember the difference between an indefinite integral, which we were doing with the plus c's, and the definite integral, which we're going to do now, is the definite integral, the answer is a number, right? Just a number. Indefinite integral, the answer is a function. Is okay? All right. So how does this change? Well, there's two different ways to approach doing a definite integral when you have to do a u substitution. We'll do it both ways so you can get a feel for like what the difference is and which way you like better or whatever. Is okay? I'll tell you the way I prefer after I've shown you both. We're going to do them for this example here. I'll do it both ways. Deal? Okay. So the u we're going to pick is 2x plus 1, right? So I have du over 2 is equal to dx. Hopefully you see, I just cranked through that pretty quickly. because this is like the 10th one we've done or something. And at that point, I think the algebra hopefully becomes easy to see. Okay, so I'm going to have then the integral from 0 to 4 of u to the 1/2. I'll do that, and then du. Everybody's okay? Yes.
You're doing u to the 1/2. Why are you pulling out another 1/2 in the front? Oh, because it would have been du over 2. You're just taking it. Okay.
I'm just doing it quick.
Okay.
Is that okay?
Yeah.
All right. I do my antiderivative. Right? But these are x's. This is a u. I can't plug them in yet. What do I still have to do? Put the x's back. So I'll do this at the same time. Everybody feel okay? Then I have 1/3, 2 times 4 plus 1 to the 3/2 minus 1/3, 2 times 0 plus 1 to the 3/2. So let's see, that's 9. 3 cubed is 27 times so that's 9 minus 1/3. So whatever, 80 over 3, I think? No, 26 over 3. Okay, that's kind of the naive approach, the obvious way you do it. The other option, which I think is easier, I'll show you now. This is the option I prefer, but both are acceptable. So initially, nothing changes. The difference is I'm going to adjust 0 and 4 so that I don't have to plug the x's back in. To do that, I'm going to take u of 0 and then I'm going to take u of 4. You see what I did? I just took the bounds and I plugged them into u to create new bounds that are like in terms of u. The advantage here is when I take my antiderivative, I can plug these in directly. So it's just like a little less number crunching involved. And the more complicated this expression is, the more benefit we have of going that route, because it just cleans up, especially if it's like a no calculator thing, right? Like this is a little bit cleaner to handle.
Just for in general, when you're finding u, how do you know if you can leave like an x in there, or how do you know if it's going to be du over 2 or stuff? Just like because the last few examples or something was like
I literally just take the derivative of u.
Okay.
So I have du dx is equal to 2.
Okay.
And then I just rearrange to get the du by itself, or get the leftovers over here by themselves.
Okay.
So it's not, I'm not choosing that, it has to be that way. Because I'm taking the derivative of what I've chosen is going to be. Is that okay?
Yeah.
So again, like, these two methods are equivalent. You're doing the exact same thing. I have no preference over what you do. I like doing this, especially if I'm doing it by hand. I think it makes life a little bit easier, but it's the same thing. Everybody's okay? Should we do another? What do I have left here? Okay, not much. I want to do this one. I'm going to skip that other one in the interest of time. Everybody okay? So here we have the integral from 1 to e, natural log of x over x dx. What are we going to pick for our u? Yeah. Mr. Kulik, you're picking the numerator now this time. Why the heck are you doing that?
1 over x is the
Yeah, because the derivative of the natural log is 1 over x. Because when Alice saw this, she's like, I see natural log of x times 1 over x. Ooh, that's the derivative of that. Yeah, let's do that. Everybody okay? So du is just going to be 1 over x dx. If I do u of 1, the natural log of 1 is 0. The natural log of e is not
No, 1.
1. Yeah, of course. Sorry, I didn't see it. It looks like you've been there for a while. How easy is this integral? Not so bad, right? Done. Notice that I didn't want to go back and get logs back involved here. Like, just give me, like, keep that stuff out of there. I'd rather deal with like polynomials than have to bring those logs back in or fractions back in. This was very clean. But again, you could do it either way, right? You don't have to change the bounds, although I think that, especially on a no calculator problem, makes life much easier to do it that way. All right, 2 shortcuts. Special cases, but useful shortcuts. Okay, if I have an odd function, you know, like canonically your odd function like that. If I'm integrating from negative a to positive a, the area under the curve, that's the area below the x-axis and the area above the x-axis should be equal, so the integral should be 0. You can use that whenever you see that you're integrating an odd function. Okay, other than x cubed, what are some other odd functions? Tangent and sine and cotangent and cosecant. Those are nice ones to remember. And then obviously tan inverse is odd as well, and sine inverse is odd as well. So those are good ones to remember. If the function is even, you know, like the x squared, the area on the left side of the y-axis and the area on the right side of the y-axis should be the same area, right? So we can just do 2 times the integral from 0 to a. Why is that helpful to us? If I'm doing this by hand, would you rather plug in negative a or 0? Probably 0, right? Multiplying, adding, subtracting with 0 is like, it's the best. So if I look at this guy, x to the 6 plus 1, odd, even, or neither? Even, right? Again, you should be able to visualize. It's going to look like that, right? Okay. So I can do that. Yes. Everybody good? And then there's some simplification or whatever, but like, we're good. Right? What's this? 307 over 7 or something? Who's impressed? Yeah. 2 times 2 to the 7 is 2 to the 8. That's 256. And then 2 times, with 14, 260 over 7. Sorry. Less impressed now. Dang it. Such a disappointment. This one. Yeah, I don't know. Here's what I noticed though, is I don't have any good idea how I would do this by hand. Right? Do you see a good U sub to do here? How is tangent related to 1 plus x squared plus x to the 4th? I don't think it is. My hope would be I graph this on the calculator, notice that it's an odd function, since the bounds of integration are going from negative a to positive a, and hope for that. It is. So it's 0. I don't have a good instinct as to well, I guess here's what I would say. No, I don't even know that. Well, yeah, okay. So, here's what I would say. 1. That's an even function, right? X squared. That's an even function, right? X to the 4th. That's an even function, right? The sum of 3 even functions is going to be an even function. Tangent is a odd function. Odd function divided by an even function should be odd. So there you go.
It's even divided by odd.
I think you're fine. Same thing, still odd. There, that's how you would do it if you didn't have a calculator. Alice is like, oh boy. Well, it is what it is. You probably wouldn't encounter something this complicated without a calculator. Okay, so far so good? All right. Questions on 5.5? U substitution will be a everyday part of your life going forward. This is something you need to have mastery over. It'll be every unit, every section going forward that you have to do integrals. We're going to see U substitution all over the place, all the time, in conjunction with other integration techniques that we'll learn going forward. Okay? So this is one like, it's like the chain rule. It's just going to be all over the place all the time from here on out. All right. Lucas had asked about wanting to ask some questions about the stuff from the homework quiz. All right. Do you remember the number, Lucas? Which number was it?
Number 11, C and D.
Peyton, what's up?
There's his question.
Of course. All right, let's see here for a moment. Well, D is the easier question, I think. Should we do D first? Lucas, is that okay with you? If h is decreasing, it means its derivative is negative. The derivative of h is going to be f of x. That okay? So if I look at f of x, where are we negative at? That's what it looks like to me. And 2 to 3. Yeah. Okay. I'm trying to think of the non-brute force method of doing this. But I'm not thinking of a good non-brute force method. Well, one answer is obvious. What value for x is guaranteed to make that integral 0? Not 0.
1.
Not 1. Those are both I'd have to check, maybe, but
2.
no.
Which question is this one?
11D. C, sorry.
4.
Maybe, I don't know. There's one value of x I know right away without having to look at the graph at all. What? 3 is the answer. Why?
Because 3 to 3 is no.
Integral from 3 to 3, that integral is 0. Doesn't matter what f is, what it looks like. I know one answer right away without having to do nothing. Everybody agree? All right. From here, I'm going to kind of brute force this and try to use my reasoning. So here is x equals 3, right? Everybody agree? So if I look at these two sections, Those have the same area above and below, correct? So those should have 0 total area. So that happens when x is equal to 1. Agree with that? Okay. If I track backwards, those also have the same area above and below. So if I go from -1 to 3, I'm going to have a negative triangle, negative, positive, all of that canceling out to 0. Does that feel okay? Okay. So I also have a -1 to 3. And then after that, everything else is negative, but then this stuff all cancels out. So that's it. Those are going to be my only spots. Are you good with what I came up with? So again, like, I didn't check every value for x. I kind of looked at the graph and was like, okay, well, we're stopping at 3, right? Where do I start at? Since we're only going from -4 to 3, I just started backwards and it's like, okay, this triangle, all the area under is gonna be negative till I get to here, and then, okay, equal triangles, good. If I back up, can I get another pair of equal triangles or equal areas? I just built backwards. There wasn't, I don't think, a good algebraic way to attack that. I think that doing geometry is what you're stuck with there, Lucas. Did that feel okay? Were there others from this 5-3 homework quiz that you wanted to look at? I have it up, so. I will say this in addition. I put an announcement on My Notre Dame, but I'm going to mention it here in class also. I made another Delta Math assignment using like topics from like this 5-3 set of topics where you're using these graphs and like doing first and second derivative tests and moving back and forth between graph to integral to first derivative, second derivative, that I think are kind of like conceptually challenging. So there's a Delta Math on there. You can do it or not. I think that they're good problems. You can get feedback right away. There's like a million different problem types on there, so don't feel like you need to finish the Delta Math. Just kind of like, if you're like, okay, I think I know what to do for this. I'm going to skip this type of problem, go to the next one. It's like, let me try this. Or like, I think I know what to do here. Let me try and get it. If you get it, it's like, okay, I guess I know what to do here. But that's there if you want to practice some more of this 5-3, how I do calculus or integrals on it with just a graph, where you're not given a function. Does that feel okay? Again, you can do as much or as little of that as you want. It's totally optional. I think it's good, but I know you guys are super busy, and it's like probably 2 hours worth of Delta Math questions, so like, don't feel like you need to do the whole thing by any means.
Do you have to do like the whole renown sums stuff for the test?
Yes.
Okay, like the long way, not the short.
So what I would say that you should be able to do for the test, is like, is something like this.
Okay.
Like if I give you a table of values, you should be able to approximate that integral using left hand or right hand or midpoint or whatever kind of rebound sums.
Okay.
So that I think is fair game. To like do the limit of the blah blah blahs, no, we're not going to ask you to calculate the area that way. But you should be able to take like the limit of the sum and convert that into an integral, or take an integral and convert that into like a limit of sums. But I don't need you to be able to validate this.
Okay.
Is that clear?
Yeah.
Okay. And that seems fair, right? That's like, just be able to do the useful parts of it, like not the tedious part that's like, well, this is kind of a pain in the neck. And requires like a bunch of properties of summations that I don't really remember, or don't think I really ever had a good instruction on at any point. So I wouldn't ask you to do that here.
Okay.
I think it's fine for homework, but like testing. Lucas,
12B.
12B. Okay, so it says find g prime in terms of f of x. So that's going to be 2, and the derivative of this is just f of x, right? So then it wants g double prime. That's going to be f prime of x. So g double prime of 2 would be f prime of 2. So at x equals 2, the derivative doesn't exist. Because it's a corner. Doesn't it? Oh, sorry. 4 and negative 2. I'll do 4 first. So 4 is here. So that's just going to be a slope, right? So like negative 3 minus 3 over 8 minus 2. So I think that's just negative 1. And then g double prime of negative 2. That's a corner. So there's no slope there.
Is that, so that's all you have to, like, what's the find the value or state that it does not exist part of it?
So this is the value for g of negative, or g of 4. And then for g of negative 2, it doesn't exist. Because you're at a corner.
I think there was one earlier.
You understand?
Like 11A.
Yep.
Find the value or state that it does not exist. I didn't find it. I hadn't found one where it like didn't exist.
It might not.
Oh, okay. I thought like the wording of it like meant that there was one.
Oh. No, I think
Like there definitely wasn't or something.
So g of negative 1 would be this area,
Yeah.
right? So that's going to be like 1/2 negative 4 plus negative 2 times 1, 2, 3. Like an area of a trapezoid. G prime of negative 1 is just going to be f of negative 1, which is negative 2. And then g double prime of negative 1 is going to be f prime of negative 1, which is, that doesn't exist. Because you're at a corner.
I got you.
Does that make sense?
Yeah.
So there was one that doesn't exist, but like, I mean, it's perfectly reasonable that these could all have numeric values, right? Like even if they say or state it doesn't exist, they're just covering their bases.
Okay. That's like that was like the part that like confused me about these questions.
Yeah.
Like what are all of these supposed to have some sort of state where it doesn't exist or
They might or they might not, right? Because we know that derivatives can fail to exist, right? Like this is a function, right? It's defined over its domain, right? That should have a number.
yeah.
But the derivative of a function may not exist,
Yeah.
right? So like, anytime you're doing a derivative and they ask you to calculate the value of a derivative, it's going to also say or state that it doesn't exist, because that's a possibility. And they don't want to put their thumb on the scale.
Yeah.
Because any derivative you calculate is going to either have an answer or not.
Yeah.
So,
All right. Thank you.
sure.
I know what you're saying. I agree.
I wonder who drinks that.
So, just FYI, the test 5 format is up here on the OneNote. Remember, this is coming next week. I have practice MCQs and FRQs and stuff up on the OneNote to practice with. So you'll have 7 multiple choice, 1 FRQ similar to the 5-3 FRQs that you should have done in the snow day assignment. Part 2 with the calculator, 3 multiple choice, 7 integrals. So definite, indefinite, U subs all mixed together.
But they're all just derivatives though.
Yes, U sub, but they're just like integral of thing, right? Like nothing crazy. And then a Riemann sum as your FRQ.
Like the one that we went, like each.
Like I showed you, like where you have like a table of values and ask you to calculate the Riemann sum like a couple of different ways.
For the integrals, is it like we have to know when to choose like what technique?
Yes. Yes. So they're going to be all mixed together. I'm not going to tell you like, use sub to find the integral. They're all going to be mixed together. You have to recognize when you need to do what. That's the hardest part, is knowing what to do. Usually, how to do it's not bad. It's like, what do I need to do here? Which one do I do? What am I doing? But actually, carrying out the procedure is usually fairly easy once you recognize what you need to do. Potentially. I mean, that's what I would hope for. We'll see how Monday goes.
Oh, what is it like? Just like a review?
We'll take our memorization quiz.
Oh, yeah.
We'll probably do the 5-5 homework quiz. And then,
You're gonna be wearing like those questions out there.
maybe take the rest of the day, do some of the MCQs that we haven't done a lot of.
Yeah, Sundays are all makeup match work.
Yeah, you got a big old one.
Yeah, I'll be here.
David's in the pit of despair.
I got a little backed up for the rest of the week. I'm actually gonna, like, Sunday morning, I'm gonna actually get started on stuff. My problem is usually I don't start work till like Sunday at like 7 o'clock, so I.
That's not enough time.
Yeah, so.
That's like one homework assignment you get done.
Yeah, exactly.
With the side of what?
Well, I'll be able to.